Hi all, thanks for coming to this session just before lunch. I'll be talking about some testing techniques which we don't normally encounter in our everyday lives, where we probably do unit tests, integration tests, or regression tests. But these will be covering some techniques which I think really help improve Python testing. And that's essentially, we'll be covering three things. So there's mocking, property-based testing, and snapshot testing. And I'll walk through each of them. I should do full screen. All the code and the slides are at their Git repo, and it'll also be on each slide if you miss this. So what's mocking? Mocking is testing a code interface without requiring the underlying code to be run. So let's say you have a database or you are fetching something from an API. So what happens when maybe you don't want to set up a whole database like Postgres, or you don't have access to the underlying API to set up a local copy of that API. So mocking helps because you have a piece of code that uses this API or database, and if you mock the API or database, then you can use its results in other testing code without actually requiring the thing to be there in the first place. So as I say, it's when the actual interface is time-consuming, maybe it requires network access, maybe you're mocking something like a hardware or a microphone or an instrument, which you really can't put it into GitHub Actions. So what do you mock the interface? And here, I'll be giving examples in Python, but all of these are very general concepts. So you can apply it to other programming languages. Just Google like mocking your language testing framework. And they usually stuff like in C++ as well. So pros of mocking is, of course, you get reproducibility. You have full control over the mocked object, which means that you don't rely on external factors. The cons, of course, is that it is ultimately a mocked object, which means it might have hidden behaviors, like maybe the API returns temperature in Fahrenheit on full moons. You can't really get that behavior in a mocked object, but that's fine. The purpose of the mocked object is to serve as a stub, essentially. There are alternatives now, because you have Docker. So many of the things like your databases, you can probably set up using Docker as well. So you don't need to mock necessarily, but that's an option. So in Python, you have this library called unittest.mock. That's in the standard library, conveniently. You can do a lot of stuff. You can mock return values of a function or a method from a class. And you can assert that the function, the mocked function, was called with certain values. So typically, you'll have some function like you're downloading data from an API, and then you're doing something with the data, right? Or you're calling a database with some SQL queries with some parameters. So when you mock the database object, you want to make sure that it's being called in the right way within your testing code. So that's what this assert function called with gives you. You can also have side effects like exceptions. So you can mock that your testing code, your code catches the exception correctly and does the intended behavior. So here's a few lines of code. There's a thing called magic mock, and if you do thing.method equals magic mock, that replaces, in a way, the method function with a mocked function. So whatever you call, the return value will be 3, conveniently. But if you do call thing.method with something, and this is typically within your actual code, right? Then within your testing code, you can check that your method was called with the appropriate values. The unit testing, unittest.mock in Python library has really good documentation on many use cases, including how to work with classes, for example. Property-based testing. So property-based testing is quite interesting. It's not that used, I've seen in the wild. And it checks that a particular property is satisfied with the code, which of course is really all unit tests. So what's new about property-based testing is that it will generate test cases for you. So normally you're writing, coming up with examples, maybe using ChatGPT to generate the examples for you, which I've done. And then you put it all in a file and you test that your code works properly. But that's looking at a very narrow portion of your state space. You might want to explore more state spaces. You might want to get edge cases. And this is a bit similar to fuzzing. If any of you have done that with compiled languages, you just throw random inputs really at a system and then see if it breaks. So as an example, normally you'll write example-based tests. So you have your Fahrenheit to Celsius, and then you parameterize. You give a couple of examples and you check. So the only thing is, this is not exhaustive. We can often miss edge cases. Applications, for example, of property-based testing is like doing testing input sanitization, like we saw in the XKCD example. If you don't sanitize your inputs, you might really have destructive results. Encode decode round trips. You have a encode decode function. Maybe you're compressing something, maybe you're encrypting something, and you want to make sure that the encryption and decryption process works properly. Obviously, you can come up with an edge case example yourself, but it's nice if it's randomly generated and it's robustly tested, right? So for example, if I put not a number here, that's really something that the code is not checking at all. And you might miss this if you're just using some examples and it works and you're like, okay, that's fine. So that's the benefit of property-based testing. It's essentially a helper will write a lot of examples. You write the property, it takes care of generating the examples for you. So Hypothesis is I think the main property-based testing library in Python. Again, you test properties and you don't need to provide examples. So for example, you have this piece of code from Hypothesis. So what Hypothesis does is you write your test cases normally, as you do, but instead of giving examples, you have this thing called a strategy. Hypothesis has very simple strategies like floats, booleans, integers, fractions, and so on. But you can also have very complex strategies. You can combine strategies. You can chain strategies together to generate the state space you want. And there are a lot of hypothesis extensions as well, which are very nice, which will generate, say, things like JSON schemas, or generate JSON that follows a certain JSON schema. So, for example, here, if you do this, Hypothesis will immediately point out that, if y is 0, you run into a problem. Of course, this is a very toy example. You can probably do it yourself, but you don't need to think of it. And it's also good for finding counterexamples, right? So if you know that a property is going to be true, but you don't know where exactly, like finding the fixed point of a function, you can just ask Hypothesis to run through stuff. And when it fails, it'll print out the example that it used that failed, and you have your answer. So that's another use of Hypothesis. Okay. Lastly is I think the simplest thing, but quite handy, called snapshot-based testing. You have a function. It processes data, does some transformations, and you want to check that the output remains stable. So very good for regression testing and data transformations. Now, of course, you can simulate this by hand. You save the data to disk, you read it, you check that it matches, and so on. But snapshot testing libraries make this very easy. You can use the snapshot testing library to manage the snapshots, and it'll save it to its own format, and you can update the snapshot every time you really need to, for example. Also useful for example, you want to check that the API from a website remains stable over time. You can use these to cache results. And super easy, for example, there's a Syrupy library in Python. if you install it with PyTest, you just add snapshot to your test function as a parameter, and you assert equals snapshot. The first time you run this, it will fail because there is no snapshot, but you can create a snapshot and then it will keep passing. So yeah, that's the talk, and now we'll do a live demo, which I just hope doesn't go horribly wrong. So the example I found is like we're in Newcastle. You want to find 2 hours when it'll be sunny. Maybe you want to go for a run or do a barbecue. I don't know. So steps are, we'll fetch data from OpenMeteor. OpenMeteor is a very nice free API. We'll process the data, and we'll find the block of the sun, right? Okay. So now we'll go to the terminal. I need to make this big. That's fine. Yeah, okay. And the correct place, yeah. Okay, so let's do. Okay, so this is the code here. So again, not doing much. I've set location, got the number of hours. I'm intentionally doing Fahrenheit to Celsius. OpenMeteor can also return in Celsius. Call the API here, check the status code. Again, process into a nice data frame. So OpenMeteor gives you like hourly data for 7 days. And what I do is that I use the weather code to filter out. So there are 2 clear codes. There's 0. So WMO code 0 is clear sky. So absolutely no clouds. So when I tested the code, it just didn't give me anything, right? You never get that here. Then you have 1, which is like clearish, some wisps of clouds, and I could get some results with that. So it's 0 and 1 WMO codes, and then this is the main thing. It just looks that basic stuff. It should be after sunrise, before sunset, in the future. And what it does is you get this mask. It's a true, false, true, false, true, false. Convert into S and blank. Concatenate that. So you get a string of S's, and you just find the S of length 2, for example, the first one. Okay. Yeah. Okay. And then to make it more fun, I also print the mean temperature there, so you know how hot it is. And that's the code. Yeah. Now, of course, this is a testing talk, right? So you want to test this. Now, this is a bit hard to test, right? There's a whole bunch of stuff going on. You're fetching data, you're processing it, and then you're printing things out, and it's all kinds of things happening all at once. So there is a version of this which is more modular, and that's easier to test. So I'll be working with that. Nice name tuple to structure the data. Instead of latitude, longitude, you have a nice tuple of location. And now everything is modularized, so you can test the fetch, only the temperature conversion, processing, and so on. So this makes it easy to test. Okay, so let me actually run this and see if it works. Okay. When is the next 2 hours of sun? Okay, it's tomorrow morning at 6 a.m. And it's 10 degrees. It's a bit chilly. Okay, that's fine. So it works, but does it work in all conditions? That's the main thing. So let's go to the test example. So this is normally what we'd write, right? You'd start with our best practices, which is, maybe I'll make it a bit smaller so I can see more. Right. So again, most of this very standard. I checked that the URL is being written correctly. I fetch data and just look at the length of the data, for example. Again, example-based tests, the usual stuff. Test the processing, and finally, I just look, again, this is all classic example-based testing. I found an example, it works, and this is good. This is good to start with. And then like sit for 4 hours, and this is reliably not going to be there, so it's okay. Okay, and then one thing that I'm doing is I fetched the data into a stub. So this is the openmeteor.json. So this is an example I did in Oxford. So it's saved, the data is saved. So it's both good for you to look at it, and also gives you a way to conveniently segue into the mocking portion of the code. So why do we need mocking? So let's run this code first. Test samples. Okay, it runs, but it's using the network. So let me turn off the Wi-Fi, and I run it again, and it's failed. So you depend on the network, and then you have this thing that requires the network to run, which is not ideal, right? You might be running code which is dependent on the network, and then it might fail in CI and so on. So let's look at the mocking. Okay, so how does mocking work? So I'm patching the request module, which is using to fetch the data. I give it a location, and this is the openmeteor.json. That's the stub, right? So I load the stub in, and what I say is that this is the main line. Mock requests dot get. So because it's request.get.json, right? So mock request.get dot written value is mock of. It's a mock object, right? It's a mock object with two properties, status code. So request.get will give me something that will have status code 200, and it will also give me a JSON function whose written value is the data. So that way, when I do request.get.json, I get the data, and I also get the status code 200. And if I do fetch, because I've patched the request module within Sunblock, that means instead of the actual request module, what will get passed is this mock request object. But the mock request object already has the get function, the return value, embedded here. So which means when I call this, and I also check it's actually called, I get the data back. So okay, and it passes. Great. Okay, so that's an example of mocking. Now let's go to property testing. And I'll just remove some examples here. Okay, so what am I doing here? Okay, so maybe I'll remove these just to show what happens. So when we have to Fahrenheit to Celsius, we want our examples to be above absolute zero. There is no temperature which is below that. So that we assert that, and reject, what reject does is sometimes you expect your code to fail, and then you use, say, value error or connection error or some standard Python exception to raise it, right? So when hypothesis gets a reject path in the code tree, code branch, then it knows that example is bad, but not the example that's failing, right? It knows that it should remove it from the search space, essentially. So it's a known case. And then there's a few more examples. This is the example I was looking at to find a counterexample. So we know that there is a temperature where Fahrenheit and Celsius are the same value, right? It's minus 40. But we are asserting the opposite of it and letting hypothesis find the result. And the last one is testing that you have 1 to 23 hours, right? You can't have 24-hour sun. No, of course, not actually, but for most reasonable latitudes, that's true. And then we test that it works for all these values. Of course, in this example, it could also be a fixed list because there's only like 23 values there, but it could be a much larger space, and then hypothesis would make it easy to find things. Again, assuming that we'll never get a 4-hour block of sun, so that seems to be reasonable to test. Now let's test this. This should fail. That's a different thing. So if you do python -m pytest, it can actually find the module. If you do pytest, it can't find soundblock. Okay, it's failed. I'm very happy to see failed test cases in this example. Okay, so it's already got example of NaN. Example like Cameo. So NaN wouldn't work here, right? So you need to remove that somehow. Okay. Let's say if I do min value. So if you do min value, that usually removes NaN from the list. But ideally, you'd have example. You'd have a catch block in your Fahrenheit to Celsius, which raises a value error. But let's look at this. Minus 500 maybe. Okay. Now we get a different error. Yeah. Because we found this minus 460, it generates a Celsius which is below absolute zero. Okay, fine. So then we do 450. But all we had to do is one line, right? So it's Fahrenheit, and this generates all these, Hypos will take care of generating all the examples for you. Okay, it's generating, and it passes. But, hang on. Why did it pass? This is supposed to fail, right? It's supposed to magically find out examples. Yes, but it's not going to go on for hours, right? And I've intentionally given a very low max examples here because it might have found it by accident. I didn't want that happening. So let's increase it to, again, 5,000. Let's see if it finds it. So, of course, this is one of the disadvantages of property-based testing is it's stochastic. So it might not, the fact that it passes doesn't mean that it's okay. It might have taken a longer time to fail. Still goes. Maybe I should make this, give it a little boost. Finally. Okay, and it's found the counterexample. So minus 40 not equal to minus 40. So, and if you keep rerunning it, it'll hit the same ones because it has a local database of failing examples. So you can always reproduce it locally. There are ways to reproduce in CI and so on. That's all on the Hypothesis website. And this didn't found any counterexample. Maybe there is, but there isn't much time left now in the talk. But it passes at least the given examples it found so far. It has passed the last test. And now if I go to the snapshot example. Okay, that's just 2 lines. Yeah, it's very short. I read the data, process it, dump it to your CFC, and look at the snapshot. So if I do that and run snapshots, okay. So because the snapshot doesn't exist, I had to create the snapshot first. So that's snapshot update, and then okay, it generates, and if I run it again, it should pass. And it passed. So if I look at the snapshot, it's a custom format. It's essentially just dumping the string. Again, it's something you can do yourself, but it just makes it easier. Okay. And there are some further links in the slides. There's a lot of things, hypothesis, JSON schema, for example, schema thesis, and so on. But yeah, these are all very interesting testing libraries, which will help catch more bugs in your code. So, thank you.
Thank you very much, Abhishek. I've got a few questions for you. With mocking, what are the best ways to avoid your tests being too closely coupled with the implementations? E.g., is your example if you wanted to replace requests with a different library without needing to update the tests?
Yeah, I mean, that's always a good question. There are ways to create specifications automatically from objects. For example, there's AutoSpec, which will, if you give it an object, it will create the specifications. But at least in this example, if you're changing out the library itself for fetching, I'd argue it's better to create a new mock. Yeah, but there are things like autospec which you can check out. Yeah.
Thank you. Any advice on mocking time passing for event triggered based on timestamp?
Sorry, what was the question?
Any advice on mocking time passing for event triggered based on
timestamp.
Yeah.
I'm assuming this is a timestamp which is coming from outside, so it's like system time or something, right? So yes, you can obviously mock the daytime now. If you mock daytime now, you'll get it. There's also this Python library called freezegun, which allows you to freeze time. So and then you just I think just people install freezegun, and then you can set the time, and then daytime now, and all those time delta stuff will all work nicely. Yeah.
I think one more question. Yeah, if property-based testing is non-deterministic, should it be combined with deterministic test too? Is there a way to make hypotheses behave in a deterministic way?
Yes, that's a good question. Yes, there is a way to make it deterministic. Of course, then you lose the advantages of it being non-deterministic, but there's a thing called seed. So you can set a hypothesis seed to make it run reproducibly. There's also ways to have, if it fails, then it sometimes generates a code, and you can use that code to reproduce it in CI. So yes, there is ways. There's a page in hypothesis on how to get a reproducible property-based testing. Yeah.
Okay. Thank you very much, Abhishek. One more round of applause for Abhishek.